Well, I see there's 7 people right now, 6 people in here. So there should be a chat in the YouTube page. So just type your questions in there, and we'll start from there. For short answers, there will be graphical questions. So you'll be asked to draw a graph, a supply and demand graph, and from there you're gonna be asked some different questions like in the problem sets. So just be ready with your supply and demand and all the relationships in there, and you'll be fine. And for the math, well, the math is gonna be only the so only what we covered in the problem sets and in the class, and there's going to be a big part of multiple choice. Anyone else has more questions? Well, oh yeah. So are the problem sets and discussion slides long enough to cover the midterm, for the midterm? Yes, that should be, well, try to study also the class slides, which are already in iLearn. That will be enough for getting ready for the test. Don't worry about the video that was shown last Friday. That's not gonna come in the test. Is there any other questions? We can solve some questions with the material too, if you want. Um, I don't know, calculating total benefits, total costs, net benefits. So I'm waiting for more questions. In the meantime, I can show you very quick the way that we work with the areas in our supply and demand. I'm drawing it here. So we have our supply and demand curve. We're gonna find our equilibrium here. So that's going to be the equilibrium price and the equilibrium quantity. Yeah. The trapezoid that forms from the equilibrium price to the, let me find another color. This trapezoid that forms, okay. This trapezoid right here is going to be our total benefits or our willingness to pay. So the way we calculate this area is we're going to calculate the reservation price first. The reservation price, remember, is when in our demand curve, it's going to be when Q equals 0. Okay, I have another question. Sorry if I didn't see it. So I have the question if the problems are going to be the same as in the problem sets, or the questions in the exam are going to be the same as the questions in the problem set. Well, the structure of the problems and the essence of the problems are going to be the same. Of course, you can't expect to have the same you can't expect to have the same numbers or the same data in the questions, but the concept in the questions are going to be basically the same. Then the next question is, when there's a price ceiling. So if there's a price ceiling of $2 a bushel, and this comes from the problem set 2, if there's a price ceiling for soybeans bushels of $2 a bushel, what is it to my diagram? So if a price ceiling is introduced here, the quantity sold to consumers is going to be so we have a price ceiling here where the price intercepts the supply curve. This will be the quantity that is going to be sold to consumers. So always when you are being asked how much is being sold to consumers, then you have to look where the price intercepts the supply curve. The next question is, any topics introduced that do not imply perfect competition, thereby making supply not equal to marginal cost? Oh, okay, so this question is about what we talk about in class very briefly about monopoly. So since we haven't covered monopoly in any of the problem sets, I would just suggest to study the concepts. I don't think there's going to be a mathematical problem regarding monopoly. So just study the concepts and you'll be fine. Then the next question is, if it's going to be recorded, yes, the link is gonna stay there. Once I'm finishing the session, it's going to be stored in YouTube, so you can watch it later. The next question is, if you have to memorize formulas. No, there's no need to memorize formulas, and just be clear with your concepts. Probably the only formula that I will memorize is the trapezoid area, which is great base plus small base times height divided by 2. That's going to give you your total benefit, and the rest are just conceptual formulas like consumer surplus, how to calculate consumer surplus, which will be total benefit minus total expense, or profit, which will be revenue minus total cost, or social net benefit, which will be the total benefit minus the total cost. So just remember those relationships, and yeah, learn the formula for the trapezoid. That's probably an important one, and the rest is just conceptual. So oh yeah, also remember the conditions for optimality. So on the supply side, on the supply side, under perfect competition, MC has to be equal to P. Yeah. On the demand side, marginal willingness to pay has to equal P. The next question is, how would I suggest using the study guide to study for the test? Well, the study guide, it's just a, let me open it. It's just a guide on the topics that are going to be covered. But I would suggest to match those topics with the class slides, and also try to the problem sets. That will definitely will help you to get ready for the exam. Find the, okay, midterm review. I'm opening the link. Yeah, so use what is said in here and relate that to your problem sets, and that will get you ready for the test. I got a question in my email these mornings asking about the invisible hand and the idea behind the invisible hand. The invisible hand is just a metaphor used by Adam Smith to exemplify how the individual decisions and how every individual looking for their own benefit leads to a social benefit. Of course, under perfect competition, as it's always our assumption here. So don't worry about it's not a Halloween concept. There's no invisible hands touching you or anything. It's just a metaphor used to exemplify how people, consumers and producers, by making decisions, selfish decisions individually, lead to the benefit for all society. So, well, I was talking about optimality. What else? Remember how to calculate marginal costs. So if we have, let me try and open an Excel sheet, and I'm just going to share my screen. Can I explain the market's equilibrium slide about the example with linear individual demand curve? It's under, okay. So this is a question about the class session 5, and it's about an example with linear individual demand curve. So let's start explaining what does linear demand curve means. What it means is that the equation that gives us the demand is going to be the equation of a line. So the structures will be this one. It'll be this one. So you're going to have an intercept, you're going to have a slope, and then your quantity. So this is the structure of a linear demand curve. Now, let's open the session 5. Session 5. Market equilibrium. let's see. Do you have the number of the slide? Or, well, I can just explain it in these diagrams. I'm going to share my screen. So in this slide, we are in a linear supply function, which is the blue line. This slide is actually telling us the what happens when there's a price floor, and the next one explains what happens when there's a price ceiling. I'm not sure what do you want me to explain in here? Maybe I'm in the wrong set of. Social welfare. I'm not seeing which slide you want me to explain. Oh, here. Okay, I found it. Sorry. Okay, so this slide talks about aggregate demand, and the reason why there's like so many lines in here is because when we are talking about demand for a normal good, we're going to sum up horizontally. What do I mean by summing up horizontally? So imagine that, well, we already know that the consumers are price takers. So what that means is they go to the market, see the price, and then based on the price, they see or they make a decision on how much they're going to consume of a certain good. So we have here an example of two consumers, which is person 1 and person 2. And we have the demand for person 1 looks like this, and it's given by this equation right here. You can see the quantity depends on the price for both of them. So for person 1 at price 2, and remember, the reason why we do this is because prices are given. They cannot change the prices. They only can decide on how much they're going to consume. So at price 2, person 1 is willing to consume 12 units of the good. Person 2 is willing to consume only 2 units of the good. At price 4, person 1 is willing to consume 8 units. Person 2 is going to is willing to consume 0 units, and this gives me an opportunity to introduce the concept of reservation price. So reservation price is where the people or the person is not willing to consume any quantity of the good because the price is too high for them. At price 6, this person is going to consume 4 units, and the reservation price for person 1 is 8. Now, to get our aggregate demand, we're simply going to sum the units consumed at a certain price. So that's why we have this line in here. And then we sum up at price 2, person 1 is going to consume 12 units, and at price 2, person 2 is going to consume 2 units. So we will have 14 units. At price 0, person 1 is willing to consume 16 units, person 2 is willing to consume 4 units, so we have a 20 here. And then since the rest at price 6 and 8, person 2 is not willing to consume anything, it just translates directly to the aggregate demand curve. So that's how this idea of summing up horizontally works. I hope that was clear. If not, you can keep asking me here in the chat. So the horizontal summation, remember, is for normal goods, just market goods, regular market goods. For public goods, we're going to sum up vertically. And the reason why is because public goods, once they are provided, they are non-excludable and non-rival. So people will make their decision in willingness to pay. So how much they're willing to pay for a certain quantity of the public good. So that's how it is summed up horizontally. So a horizontal summation will look like this. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay. So consumer A and consumer B have two demand curves for public goods in here that will look like this. So we have two demand curves that look like this. This is for public goods. Let me write it here so it's more clear. Public goods. Yeah. So how do we build our aggregate demand from these two curves? Well, we will simply look at how much is A willing to pay for 1 unit of the good. Wait, I did this wrong. So for 1 unit of the good, A is willing to pay 3, and for 1 unit of the good, B is willing to pay 4. So our aggregate demand in here for 1 unit will tell us that they're collectively willing to pay 7. Same for 2 units. So for 2 units of the good, A is willing to pay 2, 2 is willing to pay 3, so it'll be 5. And for 3 units of the good, A is willing to pay 3. Oops, sorry. A is willing to pay 3. I'm sorry, for 3 units of the good, A is willing to pay 0, and B is willing to pay 1, so this will be 1. So our aggregate demand curve will look like this. So you see how we sum up vertically, because for public goods, what is fixed is not the price, but the... Okay. Any more questions? So just to remind people that might just have joined, this will be recorded so you can watch it later in YouTube. And I'm just waiting for questions right now. I think it has a little lag, so just be patient. Okay, in the meantime, we can talk about shifting curves. Okay, problem set 1. Good. Okay, so let's assume there's a market for books. So there's a price, and we have, this is our space. So we have our space is price for books and quantity of books. We're going to have a supply of books that will look like this. Yeah. So yeah, someone told me that the lag is about 20 to 30 seconds. Yeah, it's a big lag. So just be patient. So what will happen in the market for books if the price of paper goes up? Well, what will happen is that our cost for producing books is going to go up, right? But in these axes, there is the price of books, not the price of paper. So what is going to happen is the curve is going to shift left. The curve is going to shift left due to an increase in our costs. Yeah? So now let's see what will happen with the demand. So we have books. And this is our space for our market for goods, for books. And then we're going to have a demand function that will look like this. Now, imagine that your income suddenly goes up, so you are more able to afford books. So what is going to happen is the price of books is not changing. Again, price of books is not changing. What is changing is your income. So it's an external change that is not in this graph. So that's what it's making us shift the curve. So if your income goes up, the demand for books is going to shift to the right. Like this. Now, when do we move along the curves? Well, I'm going to draw both supply and demand in this example. We will have a price of equilibrium here. Yeah. So if for some reason the price for books increases, let's say to PA, so we're going to have PA in here. We are going to move along the demand and the supply curve. So what's going to happen? The supply and demand are going to react to that increase in price. So the new quantity demanded due to this increase in price will be this UDA, and the new quantity supply due to this increase in price will be USA right here. You could be asked to do this only for demand, only for supply, or for both. Just so be clear that when we change the price of the good that we are analyzing, then we move along the curves. When we change anything else other than the price of the book or the good that we are analyzing, then we shift the curves. Anyone have any more questions? Okay, so we were talking about before this, we were talking about how to calculate marginal costs, right? So we will have, this is going to be, excuse me. So we'll have a producer A that's having a, I'm gonna just put the total cost. All of you know that, oh wait, there's another question. I'll continue in a little bit. If there are no questions, can we move along through the main points of each problem set? Well, let me finish that's kind of what I'm doing. I'm going to talk about how to calculate marginal costs. So just stay with me here. Okay. So imagine we are producer A, and excuse this. And we have the quantity and the total cost. So just remember, total cost is calculated with variable cost plus fixed cost. That's why I'm not including it here, because it's just trivial. So I'm assuming we have this total cost. So first, the average total cost is calculated with the following formula. Total cost over quantity. So it's average total cost equals total cost over quantity. Yeah? So in this case, we will have 30, 17.5, then 15, then 13.75, 40. So this is going to be our average total cost. The average total cost, what it means is the amount that is costing you in total to produce one unit of the good. So this is not marginal. So we're talking in totals here. So okay, so we have our quantity and we have our total cost. What we do to calculate the marginal cost is we follow this formula. So yeah, we follow this. So we're going to calculate the change in total cost. So let's start here. Here, we don't have any information for the 0 unit, so we can't calculate this marginal cost. So we just put a line. Important that you do not put 0 in here, because what this means is that we don't have information to calculate it. Now we can calculate for a second unit, so we subtract. So the delta T for the second unit will be 35 minus 30, which equals 5. And the change in Q, it's simply 1. And it's 1 for all of them, right? So we can just, this is going to be 1 all the time, so we can just calculate the delta TC, and that's going to give us our marginal cost. Okay, Trevor is asking about how to calculate average cost and marginal cost. Oh, okay. There's an explanation for what they are used to. Okay, let me finish with this example, and then I'm going to go over the concept. So we finally calculated our marginal cost in here. And you can do this at home and verify these numbers too. So average cost and marginal cost. Okay. So remember the conditions for optimality that we discussed about? The reason why we want to calculate marginal cost is to know exactly where the profits are going to be maximized. Remember that your supply curve is equal to your marginal cost under perfect competition. So the moment in which the price equals your marginal cost, that's where your profits are going to be maximized. Let me use this diagram right here. And I'm going to draw a price. So no, there's no need to graph average total cost and marginal cost that I know. Of course, I haven't seen the midterm, so the professor has the last word on that. But I don't think there's going to be a question to graph average total cost and marginal cost. But even if there is, you can still calculate both average total cost and marginal cost with the formulas I just gave you. So let me go back to the explanation of marginal cost first. So at this point, it's costing you 0, and you will get this much revenue, right? And the more you keep moving right, you'll be getting less and less profit up to this point right here. If you move one more unit to the right, you're going to start losing money because it's going to cost you this much and you're only going to get this much. So that's why the optimality condition is in the margins. Now for the average total cost is not used for optimizing, but it's used as a measure of how much you're spending in each unit that you produce on average. So to rephrase that, if you're going to make 2 pens, and for the first pen, your total cost is 15. For your second pen, your total cost is 20. The average total cost for the first pen is much higher than the average total cost for the second pen, which will be 10. So for the first one was 15, for the second was 10, because you're dividing the total cost by the number of units. So it's a measure of how much you're spending in each unit that you're producing at all levels of production. But that's not used for optimality. Optimality, we only use marginals, both marginal cost and marginal willingness to pay. Okay, so we have 10 more minutes in here. Let me check the problem sets. If there's no further questions right now, I'm gonna go over what I think is going to be important for the problem sets or for the exam that is under the problem sets, I should say. Oh, opportunity cost. That's an important one. Some people were confused about what does opportunity cost mean, and especially with the questions in the problem set 3. So the concept of opportunity cost is simply what you give up in order to do something else. So, for example, if you had 5 hours to study for the midterm, so you have an allocation of 5 hours, you can either choose to allocate all those 5 hours to study, or if you want to sleep, then you can choose to give up 1 hour of study to sleep 1 hour. The price variable in the graphs represent the price that supplier paid to make the good, or is it the price to sold in the market? No, the price in the graphs is the price that is sold in the market. What the producers pay to make the good is the area under the supply curve. That's going to be your total cost. A point in your supply curve, that's going to be your marginal cost. If you calculate the area up to that point, that is your total cost. So again, the price that is set in the graphs, like here, this is going to be your market price. So this is the price that they're going to see in the market, and then they will choose how much they're going to produce. Oh yeah, so going back to opportunity cost. So the concept of opportunity cost is simply what you give up. And you have to take into account that it's not always and not only monetary costs. Most of the time you're going, all the time you're going to have other costs more than monetary costs. Like, for example, if you go to the beach, you will have the cost, of course, of gas, food, parking, etc. And on top of that, you're going to have the opportunity cost of your time, which is the alternative use that you would have had for that time. I don't know why it's so bright, but anyways. So you're going to have a cost for your time, which will be the alternative use for your time. You could be working, you could be studying, and that has a cost for you. So you decided to go to the beach instead of working or studying. So that's where you're giving up. Apart from the money that you're spending at the beach, which also has an alternative use. Let's see. Oh, and again, for opportunity cost, just remember that the analysis whether you made the right decision or not is one step further. So when we quantify the opportunity cost, we only are interested in what you gave up for achieving that. And then the question of whether was it worth it or not, then that's another question that is independent from this, and it's another calculation and another concept. Let's see from set 2 if I'm missing something. So there's a question about if we are only covering sections 1 to 6 and opportunity cost was section 7 or 8. Okay, so that I don't know if he included that in the test. If it was in session 7 or 8, I don't think it's coming, but it doesn't hurt to know anyways. Let me check the slides. See. It was covering 7 or 8. Well, apparently, social welfare was section 6. And section 7 is energy and materials. So I don't think opportunity cost was covered in there. But anyways, even if it's not coming on the test, it doesn't hurt to know or to have that concept clear. So we have 5 more minutes. Also, make sure you have very clear how does supply and demand function look like. So remember that your demand function is always going to have a negative slope. Your supply function is going to have always a positive slope. So if it's a supply or demand function. And again, if you're presented with both, you can calculate market equilibrium by setting them equal, because under perfect competition, they are equal. Now we have a question about the free rider. Okay. So what about the free rider? The free rider, it's a effect that arises under public goods. So let's start by defining the two conditions for public good, which are non-rivalry and non-excludability. What does non-rivalry mean? That means that my consumption of the public good is not going to affect your level of consumption of the public good. Non-excludability means that you cannot exclude me from consuming that good. So there's no way that you can, once it is provided, you cannot tell me you can't consume this. So one of the classical examples is clean air. So there's efforts for keeping the air clean in the basins, and once the clean air is provided, no one can be excluded from breathing the clean air. Neither your consumption of clean air is going to affect someone else's consumption of clean air. However, there's people that are willing to contribute more to achieve clean air than others. But these other people, are still willing to contribute to get clean air. What happens is that when the people that care less about clean air know that the good is going to be provided already by the people that are contributing, they have no incentive to contribute at all to provide clean air. So they are free riding the efforts of the people that are contributing to provide clean air, and they are enjoying the benefits without contributing to the provision of that good. So I hope that was clear. And according to my watch, is already 1:59 in California. It's 3:59 in Mexico City. So thank you for joining in this experiment. This is the first time I do a remote session. I hope you enjoyed it, and I hope it is going to be useful for tomorrow's test. Good luck, study hard, and get A's, because it's not going to be a difficult test. So thank you again, and I'll see you on Tuesday.